Now we find the numerator is in irrational form. Already I have discussed, while finding the limits we have to rationalize this. Also, initially we put the value h equal to 0, but we find 0 by 0 form. Therefore, next step will be rationalizing the numerator. Using the formula, derivative of root x will be 1 by 2 root x. Therefore, at x equal to 2, we have to put the value of x here and we get 1 by 2 root 2. Therefore, the result is also verified. Now, as per definition of derivative of this function at this certain point, this will be the form. Then I have split this one like this. Now let us move to find the derivative of given functions at certain point. Already I have discussed that if the given function be fx, and if we are to find the derivative of fx at certain point, say x equal to a, then we have to use the definition like this: dy dx at x equal to a will be equal to limit h tends to 0 f of a plus h minus fa by h. We have to use this form. Sometimes students do that derivative. Student find the derivative of root x using the definition, then at the last step he or she puts the value x equal to 2. But that is not the way. When you are asking to find the derivative at a certain point, you have to use this form: dy dx, or f dash x at x equal to a is this one. We follow that. Number 1. Here, or let fx equal to root x. Therefore, f2 is equal to root 2. Therefore, f2 plus h equal to root over 2 plus h. Therefore, by definition, f dash x at the point x equal to 2, or the symbol is dy dx at x equal to 2 will be equal to limit h tends to 0 f of 2 plus h minus f2 divided by h. You must follow strictly this method. Then we calculate this value, or put the values like this: limit h tends to 0 root over 2 plus h minus root 2 by h. Now we find the numerator is in irrational form. Already I have discussed, while finding the limits we have to rationalize this. Also, initially we put the value h equal to 0, but we find 0 by 0 form. Therefore, next step will be rationalizing the numerator. Therefore, that will be equal to limit h tends to 0 root over 2 plus h minus root 2 whole into root over 2 plus h plus root 2 divided by h. Here the rationalizing factor is root over 2 plus h plus root 2. Now limit h tends to 0, numerator becomes 2 plus h minus 2 by h root over 2 plus h plus root 2. Now these two are cancelled. H by h form limit h tends to 0, h by h into within brackets root over 2 plus h plus root 2. Now this h will be cancelled, and you mention that since h is not equal to 0, as h is not equal to 0, we can cancel, and finally you put the value h equal to 0 here. Therefore ddx of root x at x equal to 2 is equal to 1 by 2 root 2. Putting h equal to 0, this part becomes root 2 and there is another root 2, therefore 2 root 2. Now you can check it easily using the formula check ddx of root x, that is equal to ddx of x to the power half, that is of the form x to the power n, therefore it will be half into x to the power half minus 1, that is equal to 1 by 2 root x, x to the power minus half, therefore it will be 1 by 2 root x. Therefore ddx root x x equal to 2 is equal to 1 by 2 root 2. Using the formula, derivative of root x will be 1 by 2 root x, therefore at x equal to 2 we have to put the value of x here and we get 1 by 2 root 2. Therefore the result is also verified. For this sum, if x equal to tan 2x, we have to find the derivative of tan 2x at the point x equal to pi by 8. Therefore we have to use this definition. Here a is pi by 8. First of all I calculate a for pi by 8 and got the value 1, and this one will be tan 2 into pi by 8 plus h, that means tan pi by 4 plus 2h. I calculate or use the formula tan of alpha plus beta, tan pi by 4, that is 1, plus tan 2h, 1 minus tan pi by 4 into tan 2h, that means tan 2h. Now I convert tan into sin cos. means we are going to simplify cos of 2h plus sin of 2h cos 2h minus sin 2h. Here we have converted that sin cos form. We have got the value of f pi by 8 plus h, that is equal to this one. After converting sin by cos as 10, then this will be this one. Therefore, f of a plus h minus fa, here a equal to pi by 8, we calculate and get this value. Now, as per definition of derivative of this function at this certain point, this will be the form. Then I have split this one like this. Then sin 2h by 2h to get the standard form, that is multiplied by 2 for balancing, and this one I have applied here the law of standard limit or law of limits. Limit x tends to 0, fx by gx or fx into gx equal to limit x tends to 0 fx into limit x tends to 0 gx, or limit x tends to 0 fx divided by limit x tends to 0 gx. Then this is standard limit, therefore 2 into 1 into 2. Now finally, if we put h equal to 0 here, what we get? Cos 0, that is 1, and this will be 0. Finally, it is 4. Therefore, ddx tan 2x at x equal to pi by 8 is equal to 4. Now let us verify whether we have got the result right. For that, we use this one, verification. First of all, ddx of tan 2x, that will be equal to 6 square 2x, 6 square 2x into derivative of 2x, that is equal to 2 6 square 2x. This one, how we are doing this, that we will be discussed in later classes. First, you see, we are using here directly derivative of tan u, that is equal to 6 square u into du dx. Therefore, ddx tan 2x at x equal to pi by 8 will be equal to 2 into 6 square. 2x means pi by 4, that is 2 by cos square pi by 4. Cos pi by 4, that means cos 45 degree, that is equal to 1 by root 2. Therefore, final result will be 2 into 2, 4. Therefore, ddx of tan 2x at the point x equal to pi by 8 is equal to 4. This is the answer. Thus the result is verified. In the next class or episode, I shall deduce more derivatives of some functions and work out different types of derivatives. Thank you.